everyone, this video is going to be about sequence sums. And sequence sums, these are going to be the other two equations that you need for sequences. We already saw for arithmetic sequences that we had this nth term is going to be equal to a sub 1 plus n minus 1 times the common difference. And for geometric sums, we have that the nth term is equal to that first term times r to the power of n minus 1. So that was just the r. This is going to be something a little bit different. This is the sum on there. So this will tell you, these two equations will tell you what the, say, 100th term is. But these equations are going to let you add up those terms. So I'm going to start with something simple here. I'm going to start off with the sequence 1, 2, 3, 4, 5, so on and so forth. So I could ask the question, and this will be something that we'll be able to solve for. What is the sum of the first 500 terms of this sequence? All right. So one way to go about doing this would just be to say, great, okay, I've got enough time on my hands. I can just say 1 plus 2 plus 3 plus 4. And then you just continue that pattern until you got all the way up to, let's see, 497, 498, 499, 500. So you could add up all those numbers manually with your calculator, but this is kind of a story that goes around the internet of who did it changes every time. So the story goes something like this: a teacher asks, they're trying to give their students busy work. And so they say, okay, add up all the numbers between 1 and 500. And so all the students are, diligently working on trying to add them together, except for one young genius, Elon Musk or Albert Einstein or whoever it is in this particular retelling of the story, finishes it in, 30 seconds. And the teacher's amazed and everybody's amazed. So what they supposedly do in this story is this following trick. So I'm going to write out all these numbers in the sequence, but this time I'm going to write them out backwards. All right, so in the opposite order. All right, so I start at 500 this time around, and then I make my way back down to the original 1 on there. So we're trying to find 1 plus 2 plus 3 all the way up to 500. So the idea is if I could figure out what the two of these are added together, and then I just divide that by 2, I should get just the first line there, right? The sum that we're looking for. So if I start trying to add these up, look at this first column here. That adds up to 501. Second column here also adds up to 501. And you start to see that every one of these vertical additions that I'm doing here, 501, 501, 501 plus 501 plus 501 plus 501. So really all we need to do is just count up how many 501s we have. So let's think about how many 501s we have. Well, for this one, it's pretty easy, right? I just said I want you to add up the first 500 terms. So I've got 1, 2, 3, 4, right, all the way up to 500 of these 501s. Right? So I've got 500 of these 501s, so we would say that the sum is going to be equal to 500 times 501 divided by 2. Just to give you an idea of what that number is. So that is 125,250. Right. So that's the first numbers 1 through 500. I'll add it together. So we can think about what these numbers are more generally, and then we can come up with a general solution for this. So let's think about maybe, well, first of all, this 500 number, that's pretty easy. That's just the first 500 terms, right? So if we're adding up the first 500 terms, then that's going to be that first number there. This 501, here it happens to be n plus 1, but if you think about a sequence like, let's say you wanted to add up, 2, 4, 6, 8, 10, right? So I know we can add these up together, but if I wanted to add these in that same way, you can see what's really going on here is this is just going to be the first term plus the last term, right? That's what gives you that 12. So here the first term was 1, the second or the last term was 500. So in general, what we can say is that the for an arithmetic sequence, the sum of the first n terms is called S sub n, right? And the formula we have for that is the first term plus the last term, or the nth term, right? So in this case, n was 500 up top here, times the number of terms, divided by 2. So I think the first thing that you need to know about this formula is that this is just for the sum, right? So we need to distinguish that between the formula for a sub n, right? That I wrote in the beginning there. Okay, so that is for arithmetic sequences. And if I give you the first term and the last term, and how many terms I want you to add up, then you can just plug those numbers in there. So I'll give you an example of something that's a little bit more complicated than just plugging those in. Say I have an arithmetic sequence where a sub 1 is equal to 10 and a sub 2 is equal to 13. Find the sum. Of the first, let's say 60 terms. Okay, so definitely not worth writing out all 60 of these terms and then adding them together. We have our formula, right? We've got S sub n is equal to a sub 1 plus a sub n times n divided by 2. So we're talking about the sum, so we know we're going to be using this formula here. Let's fill in what we know. So n is going to be 60 in this case. A sub 1 is going to be equal to 10, right? That was given to us in the problem. And a sub n, we're not quite sure about that. That's going to be a sub 60, right? The 60th term. We're not quite sure about that yet. But we can figure that out, right? So let's find a sub 60. I'm actually going to move this over here. Right, a sub 60. So a sub n for arithmetic sequences is a sub 1 plus n minus 1 times the common difference d. We can see here the common difference is 3. So n is equal to 60, d is equal to 3, and a1 is going to be equal to 10. So put all that information together, we get that a sub 60 is equal to 10 plus 60 minus 1 times 3. So we get that a sub 60 is equal to 59 times 3 plus 10 is going to be 187. So that allows us to fill in this missing piece of information here. Okay, so S sub 60 is going to be equal to 10 plus 187. So that's the first term plus the 60th term. We're going to have 60 of those, and then we can divide that by 2. And that is going to give us 5,910. The arithmetic version of this has a nice trick that we can use. So I showed you the trick here, right? But the geometric version isn't as nice, so I'll just give you the formula for that one. But I'm going to be a little lazy here and copy the setup for it because it's very similar. Okay. All right, for a geometric sequence, the sum of the first n terms is called S sub n, where S sub n is, and then this one, I'll just ask you to memorize it, but it's a sub 1 times 1 minus r to the n divided by 1 minus r. So I'll have a chart for all of these when we get a little bit closer to the exam date. Yeah, between this, the arithmetic version, and then the two formulas for a sub n, those are going to cover the 4 formulas from this section that you'll need to know. I'm going to go over a pretty important technique that you're going to want to know how to use. And you'll actually be using this not just for this section on this exam or even this semester. This is something that I'm going to be asking you to use quite a bit if you need it. I'll give you a reason why you might want to learn something like this. Now that you have this formula here, so R is the common ratio, A sub n, if I give you a problem where I say something like A sub 1 is equal to 3, it's a geometric sequence R is equal to 2, and yeah, that's everything I need you to know about this, right? So if that's all the information that I give you, and I ask for the sum of the first, 30 terms, then you will have all the information you need to fill in this equation, right? So I've got 3, 1 minus 2 to the 30th power. So you should get a very large negative number there, and then you'll be dividing that by -1, so it'll turn it back to being positive. Right, this is going to be some big number, but the point is you've got everything you need here. A different type of problem would be if I said, let's say, sum of the first n terms of a geometric sequence is 765, and A1 is equal to 3, and A2 is equal to 6. So your goal in this case is going to be to find n. So I'll set up the problem, I'll fill in everything that I know, right? S sub n is equal to A1 times 1 minus R to the n divided by 1 minus R. And if I fill in all the information I know, so first of all, I can figure out my R is going to be 2, right? So this time the sum was given to us, so 765 is going to be equal to 3 times 1 minus 2 to the n divided by 1 minus 2. Now, this one, you can solve for n, but that's going to involve using logarithms. And logarithms, I know, is something that a lot of people didn't get a great foundation on or don't have a super good understanding of how to use that. So in the next little segment, I'm going to show you how to solve something like this. But before we do that, it's going to involve GeoGebra. But I want to just kind of make this as nice as possible before I try to give this to a computer to solve. So I'm just going to clean this equation up a little bit more before I try to solve it using GeoGebra. So let's see, 765. So this is -1. So if I take this 3 and -1 here, I can divide by that 3 and put the negative sign out here, and that's going to be 1 minus 2 to the nth power. Okay, right, so we're solving for n here, and I'll take it to GeoGebra. Okay, so here I am at geogebra.org, and specifically, this is very important, I'm here at geogebra.org/calculator, right? So normally we're at geogebra.org/geometry, but this will only work if we're in this calculator mode. So I've got the, I'll delete this. I've got the algebra tool up here where I can type something in. And the command I'm going to use is capital S solve. So if I type in solve, I can simply wrap that around my equation. And then the only modification I need to make, so in my formula, it's going to be 1 minus 2 to the n, but you just, whatever equation you're trying to solve for, whatever variable you're trying to solve for, you would just make that an x instead. So I'm going to say 1 minus 2 to the x power. And that's just going to give me the solution right here, x equals 8. So rather than doing what some students might be doing in this situation, I know in previous years people would just test out numbers until they found something that worked. Or they would, go through the process of learning logarithms to solve for this. We just use geogebra.org to solve for this. So geogebra.org/calculator. Type solve, and then I'll go ahead and write in that whole, right, -765 divided by 3 is equal to 1 minus 2 to the x, and so we put a little note here that says we want make this variable x. Okay, so that covers all the content for today's lecture, and next time we'll talk about constructions in class.